What we're going to discuss today is the different types of options you have for heating systems in the different houses. Three basic types of systems are electric heat is one option, hot water baseboard radiation is a second option, and forced warm air is the third option. The most expensive to run for energy use is electric heat. It's less expensive to install initially, but the cost of using it is very expensive, and a lot of home purchasers do not like the thought of having electric heat in their homes because it is very expensive to run. The options of hot water baseboard is a good way of doing it. In this house, we did have electric heat here. We took the electric heat out and converted it over to hot water baseboard radiation, which is oil-fired, using number 2 fuel oil to run the boilers. Another option we have is natural gas, a very good option also. What we basically did is, when we took the electric heat out, we had to find out how much radiation we need in each room to satisfy the house. We did what's called a heat loss. By measuring the rooms, each individual room, the length and width, the ceiling height, by taking into consideration the amount of window glass, we calculate what's known as a heat loss calculation. That tells us how much radiation we need in each particular room based on its size. And then we went from there and installed the radiation. In this room, we measured, we're in a ranch-style house here. Typical bedroom in a ranch style is 10 by 12. We did the heat loss calculation based on the 2 windows that we have in here. The heat loss came up with 10 feet of radiation for the room that the room is needed. So that radiation was installed on the walls, always on the exterior walls, to cover the walls with the heat, where the greatest heat loss is in the exterior wall of the building. Cost of installation of the baseboard heat itself usually runs $6 to $10 a foot of radiation, depending on how hard it is to run it. This house is a little less expensive because the basement is open downstairs. It's all on one floor. We don't have to pass through first floors and second floors to get pipes up and encounter a lot of work to run the heating system. So a ranch-style house is a fairly easy house to retrofit with this type of radiation if you do encounter it, to switch it over from electric heat. Okay, this is the heating plant that we chose for this house. We have a water boiler, oil-fired water boiler. What we did, based on the heat loss that we did for the upstairs, based on the amount of radiation, we know the load that we need for the radiation. We were able to size the boiler, the net rating of the boiler, based on the load of the radiation. In this house, we have a load of about 75,000 BTUs that we need to satisfy the radiation upstairs. So this boiler is 110,000 BTUs input, which after it fires and with its loss of its energy from the combustion, it ends up at about 80,000 BTUs of net output. So that's enough to handle all the radiation upstairs to heat the house. Okay. The piping from upstairs we brought down into the basement area here. We ran the loop around. This is a single loop system. Comes out of the boiler on the top on the supply side. This is an expansion tank that when the water gets heated in the boiler system, the water has to expand somewhere. This tank has a cushion inside of it that allows for that expansion to take place. Air vent on the top to relieve any air that's in the boiler in the system when the system's running. This is a check valve that stops the gravity flow of the heated water through the system when the furnace is off. Comes back through the return system here to the circulator. Circulator, when the thermostat calls for heat, the circulator is on, and it's running water through the radiators upstairs to the circulator. Okay. Backflow preventer to protect the water supply to the house from any cross-contamination that might occur. And the last piece is a power venter for the flue here. One of the problems is with electric houses is when they have electric heat, you do not see chimneys in the houses. So this is a great option to use when you don't have a chimney in a house. We just take and use this, what's called a power venter, and it's wired into the boiler control wiring, and that takes the products of combustion out the side of the house in the back. And that allows you, where you don't have to build a chimney or you don't need to do any work with chimneys, to retrofit houses. It's a very good option to use. You can use them for oil or gas equipment. This is the oil burner for this boiler system. This is what creates the flame and the heat to heat up the water, to heat the radiation. One way, if you're looking at existing systems, you can tell the difference between oil and gas systems. Oil burners will always have a copper oil line coming to the burner. All gas systems will have a steel pipe leading down to the burner, so that lets you know that it's natural gas. This system was wired by electricians with an emergency switch here. Completely shuts off the system. There's also an emergency switch located at the top of the stairs. These are all code issues that have to be followed by the electricians. A system like this, completely installed with the radiation upstairs, boiler, oil tank, which we have in this system because it's oil fired, and this power venter, all the other apparatus for 1,200 square feet should run in the range with electrical $5,000 to $7,000. We chose to do hot water in this house, hot water radiation, because it was fairly easy to accomplish. Sometimes you run into houses where the basements have finished ceilings, all the downstairs are finished, the walls are done. Very difficult to run pipe and tubing through everywhere. Another option, this is usually when we go to warm air heating, is where you have an attic space, an open attic space, where you can put a warm air furnace up in the attic and run ductwork in the attic space down into the ceilings of all of the rooms. This is when we make that decision to go to warm air or baseboard radiation, based on how difficult it is to retrofit piping through the house. A good option is to put warm air and ductwork in the attic. It also gives the customer the option of air conditioning, central air conditioning, if they want it. Any of these installations should be done by licensed professionals with having permits and inspections pulled and done by the local town or municipality that's involved. Very important. A lot of codes to follow here, a lot of rules and regulations should definitely be done by licensed contractors. If you're looking in houses that are existing, you want to go into houses and look. In colder climates, you definitely want to check for frozen pipes that have burst. Signs of that are the piping. You'll see the joints pulled apart. You'll see radiators that are cracked in upstairs apartments and things like that, or houses. You definitely, if you do see signs of a house that was not de-winterized, you should definitely call a contractor, have them look at the heating plant, the heating system, make sure that everything is in good working order, because as fast as the pipes freeze and burst, the same thing happens to these type of heating systems. They freeze up just as fast, and the boilers will burst, and you won't know that until you go to fill it up and turn it on. So if you see any signs of burst piping, water piping, anything like that in a house, an existing house, you definitely want to have the heating system checked out by a contractor right away before you incur a great expense later on down the road.
All right, let's move on to the electrical portion of our videos. This is Dan from DW Electric. What he's going to do is take you to our house on 1921 Ridgewood Street and show you the service that he's doing. He's going to run 3 services on the outside of the house with a cost of about $3,500. We're going to move to the basement of the house next, and on the inside he's going to show you the 3 new panel boxes that he installed and some of the new wiring that came down through the house. The interior portion is about $2,500, so the total project on this big 3-family house is going to be around $6,000 to $7,000.
Here we're going to show you a little bit about a 3-family house. This one here, we have the 3 meter banks. We did a 200 amp service with 100 amp individual 100 amp panels for each floor. You got the first floor, the second floor, the third floor. But on this one, because you've got hallway lighting and outdoor lighting and other things like that, they require that you have an owner's panel. So we have to have an owner's meter in order to power that panel. So this fourth designation is going to be put in. It was put in for an owner's panel. New law requires that if they remove the meter, that the power cannot be interrupted to emergency lighting and smoke detectors and things like that. So they have a little lever which they build into the meter box, which bypasses the meter. So when they take the meter out, the place still has power at all times. Down on the other end, we're going to have a smaller panel, which is going to take care of the few circuits that we're going to have. We pipe each one individually into the house. Each one of these pipes will go to its own panel. And you have 2 ground rods that we have to install. You have to ground a water pipe when you're doing an electrical service. And you just have to make sure you have all the proper paperwork all done, and that you do load calculations to make sure that the service on the house that you're installing is actually going to cover the load that the apartments are going to draw. Now I'm going to show you how actually this meter bank is actually all connected, so that you only have 3 wires coming down, but yet all these panels are going to be powered from those 3 wires. You do not want to go into this panel, and most of the time CLMP has it locked. If they catch you in here, there's actually a criminal offense against you. But anyway, we've got a white wire which is called our neutral wire. It feeds this main lug, which goes across the whole bottom of the meter socket, and each one of our pipes has a white wire also, which comes up and connects to other lugs that are also attached to that main bar. And the same thing works for the top. We've got one of our hot wires coming in, goes across this upper bar, and they actually, when they produce this equipment, they install it already for us, so we don't have to connect anything between the top of the meter and those bars. They've got jumpers already bolted in all the spaces where there's going to be meter sockets. And this is pretty much the basic design of every meter bank that you're going to buy. Price range for a service like this one was roughly around $3,500 compared to a single family, which is right around $1,200. All services have to be an electrical conduit now. If you follow the pipe all the way to the top, you're going to have a weather head, which keeps the water from coming down into the electrical enclosures. Each wire comes out of an individual opening, and CLMP requires you to leave roughly about 3 feet hanging out the top so they can connect from the street. If this house already had electrical power installed, I would actually be doing the connections back to it, not the CLMP company. All right, here we have the original service that was on this 3-family house. Here we don't have an owner's meter like we do now, and these were actually where the meters went originally. They allowed them indoors back then. Now they want them all outdoors so people can't tamper with them and steal electricity from the company. This is an old fuse type setup with the fuses, and a lot of times the biggest problem with these is a wire was only good for 15 amps and everybody seemed to have 30 amp fuses, so they would screw them in and they would fit. And that's where you get a lot of electrical problems and a lot of fires in houses. In these old circuits, they had a pull-out here, which would have actually shut the whole house down by pulling that one out. Then on this system, they also had another one, which they had just for an electric range or any type of 220 circuitry. But this little system here has just two fuses in it. The 3rd floor apartment here only had two circuits going up to the whole apartment, where nowadays we generally have anywhere from 8 to 10 circuits going up to an apartment, and usually about 4 or 5 of them are just in the kitchen alone. Bedrooms, we usually put one circuit up to each bedroom, and the bathrooms, 1 circuit is also required nowadays. All right, we've run new wiring down from the house. We're trying to eliminate most of the old wiring if we could. This one here, we mark them as we run them, so we know at the end where each one's going. This one here is for the 2nd floor bathroom feed. Each bathroom, like I mentioned earlier, has to have its own power, one own circuit going to the bathroom. We're going to install these new wires into our new services over here. We have 3 identical panels, one for the 1st, 2nd, and the 3rd floor, which are powered by the meters outside, and we also have a 4th little panel box, which is called the owner's panel, which is going to have all the outdoor lighting, basement lighting, anything for common area. These panels here, most inspectors only want 4 to 6 circuits installed, so people don't install another apartment into the basements or something like that. And This is a modern day. This has all circuit breakers. Everything will be controlled on a circuit breaker, no fuses, and you can't upgrade the size without removing the breaker and putting a bigger one in, which most people won't do. So this is a much better system. It's a lot safer. It's new, and we also have to have one general outlet in the area, and you have to have illumination in the area of the panels also. This outlet here has to be off the owner's panel because it is in the basement and it's a common plug. Anybody could use it, so they want it to always be here and on in case somebody had to service the boiler or anything in the basement and they needed a plug. If there's one present and they don't have to jimmy something up to make it work. When you are buying a multifamily, you might see 2 panels if it's a 2-family, 3 panels if it's a 3-family. But what you need to do is actually go outside and make sure there's actually 2 or 3 panels, 2 or 3 meters outside powering up these panels. A lot of people, they'll just jump off of, they'll have 1 meter outside, they'll jump off of it and put another panel, and they'll make like an in-law apartment, which wasn't legal. And they'll, when it comes time to sell it, they try to sell it as a 2-family, but when you look it up on the title, it is actually only a 1-family. So you have to do some researching and make sure you actually know what you're buying before you buy it. All right, we're going to cover how to install a GFI outlet and where they're installed and why they're installed. First thing to do when you're installing a GFI is you have to figure out which wires are actually lines and loads. On the back of the GFI outlet, you'll have a line and load designation. On this here application, we actually only have a white and a black and a ground, which means we only have a line. So we're going to end up inserting the black wire where it says hot on the line side of the GFI. Now there's a strip gauge on the back of these plugs, so you can strip them to a certain length. So they're not, you don't want them sticking out too far, and you don't want them not going in far enough. Another way to tell usually the hot wire from the white wire on the plugs is the white always goes underneath the silver screw and the black always goes underneath the brass screw. And that goes for any outlet that you're installing. They always have a brass and a silver screws on them. Okay. And the last step you have to do also with a GFI is you have to put the ground wire on, which every ground screw is green. And if there is no ground screw, then it'll be designated by some other means. It'll say either equipment ground or grounding or some other way. Almost every switch and every plug has a ground attachment to it. The ground is put there for your safety in case something was to ever happen. A common practice that I have that I like to do, it's just another safety thing, is I like to tape up all the screw terminals when I'm done. This way, if you're ever removing a plug or something and you grab the side, you're not going to actually be sticking your fingers on the wires. Ugh. Just give a good wrap around the sides of it with some electrical tape. Now it's ready to be installed. You just push the wire, fold the wires into the back of the box, and you just screw the outlet on. With these boxes I use, these ones are nice. You actually can just push the screw in, and then when you're done, you give it a final twist, and it just snugs them down. It's a lot less effort. You don't have to do all the turning with the screwdriver. And then the final step is every outlet and every switch should have a cover put on it. Now these GFIs you have to install them anywhere near where there's water. All kitchen countertops get them. Bathrooms have to have them if there's a plug in the bathroom. If you're installing outlets outdoors, those also have to have them in the basements. There's many different places that need them. Like I said, anywhere where there's water, there's a good possibility that you're going to need to have a GFI outlet installed. Now, if you were to look at this outlet here, This is an old style. This is the original equipment. This was knob and tube wiring. Now you can't really designate the black and the whites from each other. So I have a special tester which I use, which you're probably going to want to hire a licensed electrician to do this step, because if you screw it up, you can actually cause problems with the rest of the wiring in the house. This wiring, if possible, should be eliminated if it's in real rough shape, and a lot of times it is, just from old age. Back in the day, they never used to use any splice caps or anything. They just used to use tape and tie the wires in any way they could get them on there. That's a big mess right there, and on this house we are going to actually eliminate this because we have the other two plugs that we've installed now that are new. One of the testers I was just mentioning is this one here is made by Amp Probe. This will tell me which wire is actually the hot wire from the electrical panel. This outlet has no power, so you're not going to see it light up, but the tip here, the white tip, will actually light red when I touch it near the wire that it senses power on. It'll only light on the black wire, and it won't light on the neutral wires, which is the white wire. That's one good way that we can test out to see which one it is. It's not 100% accurate, so you can't put your life on it. It's a good thing to test it with a couple different testers that we use.
Basically what we're doing today is we had a house here where the water heater was leaking in the basement, one of the houses. We took out the leaking water heater. We're going to install a new 30-gallon gas-fired water heater. There's basically, to install a gas water heater, there's 5 steps involved. The hooking up of the gas line, the hot water connection, the cold water connection, the flue piping to the chimney, and the relief valve connection. Okay? So first thing we'll do is we'll put the new water heater in place, and then we'll start to hook it up. Okay, the first connection that we will do is the gas connection. The previous water heater already had a gas line run to it, so it's just a matter of reconnecting the existing gas main to the new water heater. Just a matter of using some steel fittings and a union. Okay, using pipe dope here to secure the joints so there's no leakage at all. Threading into the gas valve. Okay, I'm using 2 pair of pliers. Going to hold the gas valve with 1 pair so that doesn't break or crack, and tighten in the fitting. And the last part is to connect the union together to join the 2 lines. Okay, I'm putting some pipe compound on the face of the union so that doesn't leak when they're connected and tied together. Bring the gas pipe up and in, and connect that union together. Okay, we need 2 wrenches again to tighten the union. First step in connecting the hot and cold water to the water heater is we have to use these fittings called male adapters. They're a threaded fitting by solder. Those will thread ultimately right into the top of the heater. The only thing that you have to be careful of is doing the top solder joint on the heater is not recommended because it melts this connection on the heater. So what I'm doing now is making this connection off of the heater, kind of prefabbing it here, and then I will let it cool, and then I will install it into the water heater tapping. Okay, so we've cleaned the pipe and the fitting, we've applied flux for the soldering, and now we'll solder the fitting. Okay, I'll let that cool down until it's able to be threaded into the top of the water heater. So we've pre-made the fittings to go into the top of the water heater. I put a little bit of Teflon tape on them for the connection. I'll put a little of this pipe compound on there also, which is just a liquefied form of Teflon. Okay, and these thread right into the top of the heater connections. Okay, those are going to be tightened right down with a pipe wrench or a pair of pliers. Okay, we tighten those down until they're made right into the water heater nice and tight. Then we can proceed to make the last connections for the hot and cold water, which we'll use with soldered couplings that'll connect these lines together, and that'll be the water connections. Okay, so we're going to join these two pipes together to the water heater now. We use what's called a coupling. It's a very common solder fitting. That would slide up on the piping, and I just bring the piping over, slide it down, and now those two couplings can be soldered. Okay, by doing that, that makes the final water connections, the hot and cold water connections to the new water heater. Next step is going to be to install the relief valve, which most of the time comes with all new water heaters. If not, you have to buy a new one. You can never reuse one from an existing water heater that's changed. The relief valve inserts into a tapping either on the side or the top of the water heater, depending on the manufacturer. Then the relief valve itself has to be piped down to the ground. Different codes allow for certain distances, but somehow it has to be piped directly down to the ground, which I'll do that now. The line from the relief valve is threaded into the outlet side of it. Okay, have some pipe compound on there to make the joint secure. Right, and that has to, like I said, has to go down towards the ground. Certain codes have certain restrictions on that distance from the ground to the bottom of the relief valve outlet. Okay. Final step is going to be to attach the flue piping from the water heater to the chimney. The first part is the draft hood for the water heater. This is supplied by the manufacturers. This creates the draft needed to get the products of combustion from the water heater to the chimney. These attach to the top of the water heater. They usually have some holes drilled in the top of the water heater where these connectors, these legs go down into the holes. Okay. The last part is to take flue pipe, smoke pipe, and run it up and into the chimney from the water heater to the connector of the chimney. Okay. Basically, we're going to use a vertical piece and a 90-degree elbow to finish and make our connection. The top of the draft hood has a connector on it that the flue pipe goes over, slides right down over it, and then the last connection is made into the 90-degree elbow from the existing water heater. Okay, and that basically finishes the flue piping, and then you have to make sure that the chimney, the space around the flue pipe is filled with cement, furnace cement or actual concrete, to make that connection tight at the chimney. Okay. And that's the installation of a gas-fired water heater. Electric type water heaters are a little less involved. The only things to do on an electric heater are the hot water, the cold water connections, the relief valve connection, and the electrical wiring for it, which should be there already with an existing water heater. Okay. All of these installations should be done by a professional. Average cost, anywhere, depending on the size of the water heater and the warranty of the water heater, anywhere from $300 to $500 to $600.
Hi, I'm Heather Millette from Millette Pest Control. I've been in business for about 10 years, 4 of it on my own with this company. I'm here today to walk through the house with you and inspect for wood-destroying insects, which includes termites, carpenter ants, and any kind of wood-destroying beetle. We do work here in Connecticut for Robyn Thompson of Home Buyers. We've been doing work for about 2 years for her. And what the pest control operator's job is for you is to inspect the houses you're going to be buying and selling and see if there's any insects in them that can compromise your sale or the buyer's mortgage. So What we do is we both walk the inside and outside, garages if they're there, depends on every structure is different. We look for evidence of the wood destroying insects, and then we treat them if need be so that you could buy or sell the house. There sometimes are cockroaches, rodents, rats, different things that are also involved, and we can let you know. That way you don't have a problem when it's time to sell the house with other problems that aren't going to keep you from getting a mortgage but keep someone from buying the home. I would suggest that in this field that you look around your area, meet a few different companies and touch base with somebody that you find reputable. Usually smaller companies are a little bit easier to work negotiations with. If you're going to be giving a lot of volume to someone, they'll be willing to bring their dollar cost down for you in most places. There's some companies that won't touch real estate work. So look around and find someone that you can touch base with and feel comfortable with, and you can have a nice working relationship with the company so that you're not spending a lot of extra money on the treatments, and you can actually make a little more money in your pocket. So it helps to keep everyone busy if you're going to give them volume, so someone will be willing to work with you. We're in the garage and we're checking out the sill plate. It's a wooden sill plate, and when we poke, which is part of what the inspector's job is, if it breaks apart, it's then their job to decide if it's carpenter ants, termites, if it's just wood rot, or if it's something that needs to be addressed. This particular damage looks to be termite, and it's also mixed in with some wood rot. There's no live termites in here right now, and it's also winter in New England, but there's also no signs of a treatment done on the concrete here. So as we go down, it's all soft. So this is going to warrant a treatment if there's no paperwork. You want to check if there's been a treatment done by your person who owns the home now. You may not have to do a treatment if it's something that's under warranty. So you always want to check that, because you may have something that's currently warranted and you don't need to touch it, you just need to transfer it. Some people charge for transfer of home ownership. Most companies don't. It depends on which company you're using. In the inspection, what the job is to poke. You want to get someone that's going to spend the time to poke around and look, both high and low, because there's water damage up here, but it doesn't seem to be termite infested. If you look up here, you'll see that there's some droppings and cobwebs. They actually look to be mouse droppings. Sometimes you'll find carpenter ant droppings, bodies from carpenter ants, or sawdust. That's what we call the frass of the carpenter ants. And it's common to have more than one problem in a situation, because if the wood's damaged and the wood is what we call 20% moisture content or more, you're going to have different insects that are going to want to live in it. So make sure you get an inspector that takes the time to poke and prod and doesn't just walk through. So you might want to, meet them at first, see how they do their inspections, because if they're running through and just giving you paperwork, you might end up getting burnt in the end on something. Over here you can see clearly that there's light coming through, and if you poke at it, it goes right through. It doesn't appear to be from insects. It actually appears that maybe the roof's damaged back there, but that's not part of my inspection. We do not talk about water damage. We don't talk about mold and fungus, things of that nature. So it can be something that can be brought to your attention, but if it's something that's really concerning you, you may need to find someone that you're working with in the construction trade to let you know if it's something that you can take care of or is going to cost a lot of money. Sometimes with termites, if you don't poke, it looks fine on the outside, but they're eating through the inside. And it all feels good around the rest here. And again, there's no drill marks, so this will have to be treated. On the outside of the house, you check the window sills, especially when they're wood-to-ground contact like this one. And you may have to get on the inside and check some more. Take a good look around. On this house with these, there's not a whole lot to see. And then the window wells have covering, so you can't check those. Sometimes ants like to go in underneath here. There's not going to be much to tell on this one. With this rock wall, the granite, termites sometimes come up here. I know this isn't common in Florida. Your structures are different, but it's the same type of thing. You do have different termites. Here we have subterranean termites. And in Florida, you deal with the subterranean and the drywood. We don't have the drywood problem here. So it's a little bit different there. You make sure you find someone that's, knows what they're talking about and didn't come from up east to start a company and they're not familiar with it at all. There's also baiting for treatments that can take place. It's a quick, easy setup, and then it's a maintenance monitor. It doesn't require the drilling that we're going to have to do here, but it takes a good 2 years to get any kind of kill, per se, on the termites. So you may want to check into that. If someone's trying to sell you that, you may be better off just doing a regular traditional treatment when you're buying and selling a house, because you're going to have your new homeowner buying into a maintenance contract, or else it's going to be no good. On the hatchway and cellar doorways that we have up here in the east, we check all around the framing, because termites, this is a top hot spot, front porches, stoops. In Florida, if you have a porch that's attaching to the house, that's going to be a hot spot to be checked. And the crawl spaces down there will have to be looked in. I know a lot of you have them, and down there you definitely have to get someone in there and look for the mud tubes. Another spot is always where the headers meet. It seems like it's just damp here, but it doesn't seem like there's anything going on. And then there's the porch. Porches and entries will always breed termites, because it's dark behind here and the tubes can come up. So you always want to take a good look around and poke. This is an older house with a lot of coverings that you can't see and a lot of no access points. Like, for example, there's no access underneath here unless there's something from the inside, so that'll have to be marked as a non-accessible area. And have your home buyer or owner just know that if they ever want to make access, they can call a company and have them check out in there, because there could be something going on in there that nobody could tell. What we're going to do now is we're going to do the drilling in the garage, because we did find termites. What we have to do to protect the garage from the termites is we have to make a full barrier with a liquid termiticide around both the inside and the outside. We achieve this by drilling holes around the foundation, and we're going to inject a chemical application of liquid in, which is basically going to come up around the footing there so that the termites can't get up to the wood. Because this is a wood footing, we're actually going to drill the wood itself also and inject the wood directly. This way, if it takes the new folks time to get around to repairing it, they may not. There's at least protection there so that it doesn't get eaten on them, because if we leave it in the wood without treating the wood in this situation, it would continue. So what we do is we actually go around the whole entire interior and exterior perimeter, and we drill the holes approximately 12 to 18 inches, sometimes closer depending on the structure if we're having a problem getting the treatment to actually go where we want to. So a lot of it, goes by how the treatment's going. There's some very basic rules in termite treatment, and then there's the real thing when you're doing it. So things sometimes change when you're doing the treatment. The cost of a termite treatment on an average size house, which I'm going to say is about 2,000 square feet, ranges anywhere, depending on the problem, from probably $400 to $600. If I was doing a treatment for any regular homeowner, it would be more. But because I'm doing the treatments with a company that I'm working with all the time, I bring the price down. So that's why I suggested you establish a relationship with a company and try and work out. It's not really a volume discount, it's just the fact that you're going to keep them busy with work all the time. Same thing goes for the inspection. The inspections I run are anywhere from $65 to $85, $95, but our prices have gone up, and if you were a regular person calling from the Yellow Pages, it would be $125 and up. But because we do work with these folks all the time, we give them a different rate. So you just need to take the time to try and establish that relationship. It'll save yourself, again, some money. And if things need to go up, they can tell you. But it's not brain science. It's pretty simple treatment. Just find good people to do it for you. And we'll drill a couple holes just to let you know what we're talking about. This is an older structure, and what I'm finding here when I'm drilling, which is why I say things change as you do it, is this is some sort of heavier footing that's going around. So I'm going to need a longer drill bit there. And this is where they poured the lighter amount, but yet there's still something underneath. Depending on the construction, sometimes things change as far as you need to drill a little more, or it's really easy to pop a hole. So I'm going to have to get another drill bit on the inside here and work a little bit more into some of these holes so that the liquid application that I put in will take. Now that we've got these two holes started, what we would do is normally go all the way down the whole inside of the garage. I'm going to go outside so you can see that the outside's done too, and then we'll come back and pump. And once I pump, I'll even talk about if this was a carpentry job for you, or a powder post beetle job. And this is what we would do around the entire exterior, except for in front of the garage door frames. The goal is to protect the wood so you don't have to do this entire area. So this is one of the things, when we're done, we patch these. So you want to check, if someone's saying they're drilling the work for you, this is what you look for, drill holes. And these are closer than 12 inches to 18 inches apart. But it's a little cold up here with the soil, so what'll happen is when I put the treatment in, it's going to hit where it needs to hit with the cold ground. It's not frozen because it's quite warm today. And if this was an ant job, what we would be doing is spraying with a regular little tank on the inside and outside, and if we could find an area, like if the ants were in where that termite board was over here, we would actually drill a few holes, and if we can inject something in there if we needed to, powder and whatnot. So the termite work is the harder of the two. So the price should be more for this. And I told you what that was earlier, probably anywhere from $400 to $600. Carpenter ant jobs probably would run you, I'm going to guess, and then anywhere from $150 to $300, and it shouldn't be more than that with some type of warranty for you to pass on. One other thing we do a 1-year warranty, both with our carpenter ant jobs, our powder post beetle, and our termite, for the simple reason, this way you're passing on, you're standing behind your work. We normally would charge more for that, but we don't want anyone to feel like they got burnt in the process, so find someone that'll work with that. Some folks will do 5-year warranties on termite work. We still do 1 year, and we offer what we call a renewal. It's for X amount of dollars, usually 10 to 20% of the treatment cost, so that the new buyer can have you come in and inspect every year. This way it's taking some of the hard costs off you in the beginning, and it'll pass it on if they want to hold that warranty for the termite work to the new buyer. It's a way of making it a little easier on everyone as far as cost of dollars up front. And powder post beetles and a few other type of beetles, you actually can treat with Boracare, which is sprayed on. It's a little more costly than carpenter ants. Again, depending on what the problem is, you're probably in a couple $100 range. If it's a whole area, for example, a barn, it could be up to $1,000 or $2,000, but I don't think you're going to have that problem down in Florida, but you can up in the east, so it all depends. That would be a very big powder post beetle job. And the tenting that takes place in Florida, I'm not sure what the cost of that is because it's very dangerous work, so I would check around and actually find some folks that do it, get some quotes. It is dangerous work. It takes a lot of expertise. It's a very deadly gas that they're using, so I would expect that it's going to be up into at least $1,000 range for drywood termites. So look around on that and find a company who's reputable and licensed in it. Check around on them because it's not something you want to get involved with the wrong company. And I'll get ready to pump some holes for you. We're going to pump these holes with the liquid, and this is called a sub-slab injector. What it does is it locks on these holes and it pumps the liquid. We just stick it in there, and we lock it, and then we pump. And as you can see, there's a little liquid coming up there, and that's normal. And what this does is at 180 degrees, it actually shoots this liquid out to hit the whole area into the ground. And we have to pump these. If this was just dirt out here, what we would have done is actually dug a bit of a trench with a little trenching tool like a pickaxe. It's light, and then we just fill all the soil in. It's easier than actually drilling in some cases, and we actually treat all the soil. And then once we finish treating all these holes, we plug them up with concrete. And you can see how it comes out there, especially over here, because of the pavement. And what it's doing is it's going to hit all underneath here and up to here so that the termites can't sneak in this way. And this chemical is called Telstar. All the chemicals on the market right now are good for 5 years. They say 25 on the labels, but they're all breaking down in 5. Telstar is the newest chemical out, and it's supposedly lasting more 8, 10 to 11 years, which is why all of us are spending more money on it. But retreats are part of life, so you definitely want to get some kind of warranty that you can fix up on it. And on an average house, you're probably going to have someone be pumping anywhere from 50 to 150 gallons. It really depends on the problem, the type of structure. Usually it's like 4 gallons for every 10 linear feet that they're pumping. So it takes time to do the pumping as well as time to do the drilling. So it's something that can take, on a garage like this, if I was working through and I wasn't taping this for you folks, I could probably get it done in 2 hours, and that's just hustling big time. A regular house, you're talking 4 to 8 hours, depending on if you have a company that's doing a 1 or 2 person crew. And you want them to do it quickly for you, but you also want them to take their time because they can hit pipes and things like that. And you want to make sure that you're not doing that because that will cause you more problems in the long run. And as it pumps where it goes, it'll start to seep out like it is from the back, and you know that it's reaching its area. Inside the house, you want to poke on the beams. In this case, there's some old foam insulation here. You can't really see what's going on underneath there. And there's some, what we would call frass here, but that actually looks like it may have been from when they cut and put this heating duct in. So your inspector's job is to actually look at the frass and find out if it's just from regular woodwork or if it was from insects. And that should be something that they could tell readily. And on the inspection report, it's nationwide, it's the same report that we all use. It's the MPCA 1 form. It'll say that there was something, there's a spot to say that there was something here. So that we're all working off the same report. The National Pest Control Association made sure that it was simple to understand and read for everybody, and it protected both the companies doing it as well as the buyers. Because what we're looking for is any evidence of wood-destroying insects. It's not really the pest control person's job to say whether it's structurally sound or not, even though, in our opinion, it could look very bad, and we know it is. We are not building contractors, so you may need to get a building contractor in, because on that report, even if you ask your exterminator to say, gee, is this something that's structurally going to be a problem, and they say yes, and it clears it, or no, they didn't have the right to really say that. So they should say, gee, you really need to have someone look at it, because if anything ever came to court, they're not the ones to be saying it, because we know about insects, we know about damage, but we don't know that the structure is or is not going to fall down, unless they're also a building contractor, which some folks are, because they'll do the termite repair. So keep that in mind. That's an important thing to remember, because there's been many occasions where I've been asked to solve the problem by saying it is or isn't, and I really can't do that, and I really could get everybody in trouble by doing it. So the job is, again, to look at the sill plate all around. On this sill plate, you actually cannot see, this is a running board, and you can't see the sill, so that would be marked off. And then there's window sills further down, and we're having a little bit of a light problem. So I can't take you around the whole house, but there's also going to be beams that are shooting up and down. And they want to check that. This is an older structure, and they could be coming up from the ground because the cement actually has parts of dirt and rock coming through it. So they should look at the entire inside of the structure, even at the rock wall, to make sure that there's no termite tubes coming up. If this was just a crawl space, you just imagine it's about this high, and someone's going to be going through it looking for the same things, just in a smaller area. I guess the biggest thing you should keep in mind, again, with the termite inspection, is to make sure they do look around and they poke, because this could look just fine and then they poke it and it goes right through. It's very important to make sure you have someone that actually takes the time to poke and to look around. And this looks pretty good in here.
This now concludes our third segment entitled Mechanical Systems and Structural Elements.